Ever wonder why your socks disappear in the washing machine? Perhaps it's the same reason 95% of our universe seems to have vanished. Now I know what you're thinking. How can 95% of the universe just up and vanish? Well, that's where dark matter and dark energy come into play. These two elusive and mysterious entities make up the vast majority of our universe, and yet we know so little about them. You see, the universe is a bit like a cosmic jigsaw puzzle. And while we've managed to piece together some of it, there's a large section, about 95% to be exact, that we're still trying to figure out. That missing piece of the puzzle, that's where dark matter and dark energy reside. Dark matter and dark energy sounds a bit like a comic book duo, doesn't it? But this pair is far from fictional. In fact, they're very real, and they have a profound impact on the way our universe behaves. Dark matter, for instance, is thought to be the invisible glue that holds galaxies together. Without it, galaxies would just spin apart and go their own separate ways. Dark energy, on the other hand, is believed to be the reason the universe is expanding at an accelerating rate. It's like a cosmic speedster, pushing galaxies apart faster and faster. But here's the kicker. Despite their significant roles, these entities remain largely invisible and undetectable. We can't see them, we can't touch them, and we can't measure them directly. They're like the universe's best-kept secrets, hidden in plain sight but just out of reach. So the next time you find yourself a sock short after doing laundry, don't be too quick to blame your washing machine. After all, it might not be the appliance's fault. Perhaps that missing sock has just got caught up in the cosmic mystery that is our universe. So, next time you lose a sock, don't blame your washing machine, blame the universe. Imagine having a roommate who never shows up, doesn't pay rent, but their presence is somehow felt. That's dark matter for you. Now let's get our hands dirty with this cosmic conundrum. Dark matter, as the name suggests, is dark. It doesn't interact with light or any other form of electromagnetic radiation, making it impossible for us to see directly. But here's the catch. While it's invisible, it's got a gravitational pull. This means it influences the motion and structure of galaxies and even the universe's expansion. Think of it like a cosmic puppeteer, pulling the strings behind the scenes, shaping the universe as we know it. Quite a powerful roommate, wouldn't you say? In the grand cosmic scale, dark matter is like the invisible giant, dwarfing everything else. It's estimated to make up about 85% of the matter in the universe. Yes, that's right. Most of the universe is made up of something we can't even see. So you might be wondering, how on earth do we know it's there if we can't see it? Well, the answer lies in its influence. Just like you might not see the wind, but you see the leaves rustling in its wake. We see the effects of dark matter on visible matter. Scientists detect dark matter indirectly through its gravitational effects. We see galaxies spinning at speeds that would send stars hurtling into the cosmos if only visible matter were at play. But they don't. Something unseen is keeping them in check, like an invisible cosmic leash. That's our elusive roommate, dark matter. And as our understanding of the universe deepens, so does our curiosity about this invisible giant. We're still piecing together the puzzle, exploring hypotheses, and conducting experiments to learn more about dark matter. So dark matter might be the universe's most elusive tenant, but we sure know it's there. Ever tried to catch a bus that's always speeding up? Welcome to the world of dark energy. Just when you thought the cosmos couldn't get more perplexing, we enter the realm of this elusive cosmic speedster. Dark energy, my friends, is a hypothetical form of energy that permeates all of space and is believed to be the driving force behind the accelerating expansion of our universe. Yes, you heard it right. Our universe is not just expanding, but it's doing so at an ever-increasing rate. It's like a cosmic bus that keeps getting faster and faster. But what is dark energy really? Well, that's the million-dollar question. Despite making up about 70% of the universe, dark energy remains shrouded in mystery. It's the phantom menace of the cosmos, the invisible force that defies our current understanding of physics. There are several theories floating around in the scientific community trying to explain this cosmic conundrum. Some propose that dark energy is a property of space itself, a result of quantum fluctuations. This is often referred to as the cosmological constant, a concept put forth by none other than Albert Einstein. Others suggest it could be a new kind of dynamic energy field or fluid, something that changes over time and space. Some even go as far as to suggest that it might be evidence of a whole new universe, but the truth is we're still not sure. Despite our best efforts and the most powerful telescopes, dark energy eludes detection and understanding. It's a bit like trying to spot a ghost in the dark. You know it's there, you can feel its presence, but you just can't see it. That's the beauty and the frustration of studying the cosmos. It's full of mysteries waiting to be solved, enigmas that defy our comprehension, and dark energy is one of the biggest ones out there. So, if you thought keeping up with your schedule was tough, imagine trying to catch up with the universe. If dark matter and dark energy were a superhero duo, they'd probably be Invisible Man and Speedy Gonzales. Picture this. The universe is a vast cosmic dance floor where dark matter and dark energy are engaged in an eternal tango. It's a delicate balance, a dance of gravity and expansion that shapes the cosmos we live in. Let's start with our first dancer, dark matter. This invisible giant is the glue that holds galaxies together. It's like the strong, silent type in a romance novel, always there, always holding things together, but never really seen. Its superpower is gravity. It pulls things towards itself, keeping galaxies from flying apart despite their high rotational speeds. On the other hand, we have dark energy, the cosmic speedster, always wanting to stretch its legs and expand. It's like the restless wanderer, never content with staying in one place. Its superpower is a repulsive force that works against gravity, causing the universe to expand at an accelerated pace. Together, they form the dynamic duo that governs the universe. Dark matter, with its gravitational pull, tries to keep everything close and cozy, while dark energy, with its repulsive force, strives for space and expansion. It's a cosmic tug-of-war, with galaxies, stars, and everything else in the universe caught in the middle. But here's the catch. They balance each other out. While dark matter pulls everything together, dark energy pushes everything apart, creating a cosmic equilibrium that allows galaxies to form and life to exist. It's a delicate dance, a balancing act of epic proportions happening right over our heads. So the next time you look up at the night sky, remember the dynamic duo, dark matter and dark energy. They may be invisible and elusive, but their dance shapes the universe, from the galaxies swirling in the night sky to the very existence of life itself. And you thought your relationships were complicated. Try being dark matter and dark energy. Ever wondered what the universe's retirement plan looks like? Spoiler alert, it involves a lot of dark energy. As we gaze into the distant future, the universe's fate lies in the hands of two enigmatic entities, dark matter and dark energy. They're like the puppeteers pulling the cosmic strings, shaping the universe's destiny. Let's start by imagining a world where dark energy reigns supreme. This scenario gives rise to a theory called the Big Rip. Not the most comforting name, right? In this model, dark energy becomes progressively stronger, eventually overpowering gravity to tear apart everything from galaxies and stars to atoms themselves. It's like the universe is on a never-ending growth spurt where it just can't stop expanding. Now let's take a detour to a slightly less dramatic but equally fascinating theory known as the heat death. This theory suggests that the universe will continue to expand, but at a more leisurely pace. Over trillions of years, stars will burn out, galaxies will drift apart, and the universe will cool down to a state of maximum entropy. In simple terms, it's the ultimate chill-out session for the cosmos. Lastly, we have the Big Freeze, which is essentially the heat death's colder cousin. In this scenario, the universe expands at such a rate that it becomes too cold to sustain any form of life or activity. It's like the universe decided to move to the Arctic and forgot to pack its thermal underwear. These theories might sound a tad morbid, but remember, they're just theories. The universe is a mystery wrapped in an enigma, and we're still trying to unwrap it. It's like trying to solve a cosmic Rubik's Cube that's constantly changing its patterns. So the universe might have a gloomy retirement plan, but hey, at least it's not worrying about a 401k.